Hello, this is MEI Further Maths Core Pure. We're in the first vectors section and on the second video on the scalar product of two vectors. You can watch the video straight through, but you will probably find it helpful sometimes to pause the video and try things out for yourself before continuing to watch. We already know how to add and subtract vectors, and we can multiply vectors by a scalar. But what about multiplying two vectors together? There's more than one way that we can usefully define this. The one we're going to look at in this video is called the scalar product, and it's the sum of the products of the corresponding vector elements. It's really useful because it gives us a way of finding the angle between vectors. We use a dot symbol to indicate this operation. Don't use a cross for this product. A cross product of vectors is a completely different operation. So, to find the scalar product of two vectors in two dimensions, simply multiply the corresponding elements. Here's a numerical example. If I want the dot product of the vectors 2, 5 and minus 1, 2, then I do 2 times minus 1 is minus 2, 5 times 2 is plus 10, and that gives me 8. We can do the same thing in 3 dimensions. So in this example, P dot Q is equal to 2 minus 4, 3 dot minus 2, 1, 3. Which is minus 4 plus 9, which is 1. If you have vectors which are written in IJK form, you may well find it easier to write them as column vectors before doing the dot multiplication. So, taking care of the second one, that's 3i, no j's, and minus 1k. And that for the dot product gives us 1 times 3 is 3, minus 2 times 0 is 0, and 5 times minus 1 is minus 5, giving us minus 2. The scalar product is sometimes called the dot product because of the symbol that we use. It has a size but no direction. Note that the scalar product is commutative because we are simply multiplying numbers together, and multiplication of numbers is commutative. Here's an alternative definition of the scalar product. Notice that the angle theta is measured between the lines which are going both in the same direction. So they're either both going outwards, or in this case they would both be going inwards to the point, but that will give us the same vertically opposite angle. This result can be proved using the cosine rule. Try drawing out the triangle and using the cosine rule to prove the equivalence. If you get stuck, look in your textbook. There are more notes on integral or in your textbook on the scalar product. That's the end of this short video. The next video in this series is on finding the angle between two vectors.